Okay, today we're going to do our fourth tab of our foldable on Unit 15, which is circles, and today we're going to talk about arc length. And it'll be similar to yesterday because the arc length is similar to the central angle and other angles that we talked about yesterday. So again, we'll have a few notes, so just try to write down the drawings. They're probably most helpful, and write down some of the definitions too if you need to refer back to them. Okay, so you guys know that there's 360 degrees in a circle. So basically what we're going to do is we're going to go ahead and find the whole circumference of a circle. Okay, that's the distance all the way around. And then we know the arc length, which is right here in this picture, is just a fraction of that circumference. So if I know the central angle here, okay, I can use that to find the fraction of the total arc length going around the arc. Okay, and that's what we're going to do. So you can write this down real quick. I'll try to write it similar to this, but again, I'm going to find the circumference of the whole circle, and I'm just going to multiply by the fraction that the arc is of that whole circumference. Okay, so on this picture, we know that the arc we're trying to find, the arc length is right here. Okay, that's what they want to know. So what I'm going to do is I'm going to find the arc length of the whole circle. So imagine I find the arc going all the way around the circle. And I'm just going to take a fraction of that to find the arc of this part right here. So it said on the last page, the arc going around the circle is called the circumference. And it said the circumference is equal to 2 pi r. Okay, so I'm going to go ahead and find that. So in this problem, I have 2 times pi, and r is your radius, and you can clearly see that your radius is 12. Okay, so what I know, if I multiply those together, 2 times 12 is 24, so it's 24 pi. Okay, that's the distance all the way around the circle. So I only want this fraction, though, that's right here. And so we know the central arc is going to help make that fraction, or the central angle is going to help make that fraction. So this central angle is 45 degrees, so see if this makes sense. So 45 degrees out of 360, that's the whole distance around the circle. I'm going to take that fraction, so I'm going to take that fraction of the circumference, so of 24 pi, and I'm going to go ahead and multiply that together. Okay? Now, I'm going to do this, and I'm going to leave pi in my answer. If they want me to leave pi in my answer, really all I'm going to do is multiply 45 over 360 times 24, and I'm going to write that answer, whatever that is, next to pi if I want to leave pi in my answer. So let me go ahead and do that on my calculator and reduce it. Alright, so if I want to do that, I'm simply going to go to my calculator. I'm going to go ahead and put in parentheses 45 out of 360, so 45 divided by 360. And I'm going to put times 24. I'm going to go ahead and hit enter. That's easy, it's just 3. So my answer should be 3 pi. If it was a decimal or a fraction, what you could do is go ahead and hit the math and then go and change it to a reduced fraction using the reduced fraction button on your calculator. So I'll go back, I just put this in my calculator, I realize that's 3, so that should be 3 pi is my answer. If they want that as a decimal in your calculator, you can just type in 3 and pi and hit the pi button. And if I do that, if they want that answer, it'd be 9.42 if I rounded it. So 9.42. Okay, just look at the Math Excel, see which way they're asking you to do the problem, count how many decimal places they want you to round to. Okay, this one's similar. You don't have a central angle here, but I'm still going to find this arc length right here. Okay, so what I'm going to do is find the circumference of the whole circle, the distance all the way around, and I'll just take a fraction of it, just like I did in the last problem. So again, circumference is 2 pi r. 2 pi, and in the problem they tell you the diameter is 16. So the diameter is the distance from here all the way over. Okay, if that distance is 16, then half of that is the radius. So your radius should actually be 8. Okay, so the circumference, the distance all the way around this circle right here, ends up being 16 pi. Okay, so again, I need to figure out what angle my central angle is, which would be right here. Okay, in order to find that. If you remember before, this tells you this angle is 34 degrees right here. Okay, what that means is the arc across from it right now, the arc's angle should be double that. Okay, which is 68 degrees. So you know the central angle is actually 68 degrees. Okay, and that's what you would have learned yesterday. If this over here is 34, okay, the central angle is double. Okay, it's 68. So I know that 68 out of 3/60ths of the triangle, because there's 360 degrees, I'm finding that arc. So I'm just going to simply multiply that again times 16 pi. And like I told you before, on your calculator, it's easier just to multiply 68 over 360 times 16, and I'm going to write that next to pi. Okay, a lot of them want pi in their answer, some of them don't. So I'm going to go ahead and do that on my calculator now. Okay, so I'm going to type in 68 out of 360 degrees is my arc part, and the whole distance around the circle we said was, let me look back real quick, 16. I need to multiply that by 16, so times 16. I'll hit enter. Okay, this one is a weird decimal, so again, I'll convert it to a fraction. So I'm going to hit math in the fraction bar and hit enter. And so 136 over 45. And 136 over 45. So I'm going to go back here, and I know that this is 136 over 45 pi. And again, if I want to do that part of my calculator, if they ask me for the decimal version, okay, all I simply got to do is type that in next to pi. So let me do that real quick and show you. So let me use parentheses. So 136 divided by 45 times pi. Oh, just thinking for a minute. There we go, times pi. And enter. Okay, so 9.49 if I had to round to the nearest hundredth. But again, I don't know what Math Excel will ask you. Okay, so 9.49 is the decimal version. So either that or that, depending on how they ask you for your answer. Okay, last question here. It says find the arc length from B to C if R equals 5. So again, I'm going to find the circumference like I've been doing on each one. So that'll be the arc all the way around here. I'm going to find that first. So we know circumference is equal to 2 pi r. So in this case, 2 pi, and we saw the radius is 5. So 10 pi. Okay. And so they want the arc from B to C. So B to C. So really, I need to know this angle right here. I need to know that angle. So if you remember from yesterday, if you know this angle, that angle and the central angle are supplementary. That means they add up to 180. So 50 plus 130 ends up being 180. So I know that 130 out of 3/60ths of the circle creates the arc. So I'm going to multiply that again by the circumference. And again, what I'll do is I'll just multiply the number part, and I'm going to write pi next to my answer. So I'm going to do 130 over 360 times 10, and I'll just write pi next to my answer. Okay, so let's go ahead and do that on the calculator. So we got 130 out of 360 times 10. Okay, so again, I get kind of a weird decimal, so I'll change it into a fraction. So math, fraction, enter. So 65 over 18. So 65 over 18 pi is going to be my answer. So 65 over 18 pi is my answer. And again, you can type that in to find the decimal if you need to.